Hello and welcome to this new video. In this video we are going to advance from where we ended, and we are just going to look at how to calculate the distance along the circles of latitudes. So you can see that in the previous video that I sent to you this morning, we looked at how to calculate the distance along the circles of longitudes. So now we are looking at the circles of latitudes. Okay, the lines that run from the west to the east and heading in the directions north and south. So I have a diagram with 2 points, point A and point B, which lie on the same latitudes but different longitudes. So you can see point A and point B are lying on the same latitude, which is 40 degrees north. At the same time, you would notice that point A and point B are lying on two different longitudes. So point A is lying on longitude 15 degrees west and point B is lying on 30 degrees east. So this is the reason why now we are calculating the distance along latitudes, because the points that we are calculating for are lying on the same latitude. In the previous video, you would notice that the points we were calculating were lying on the same longitude. For example, here x and z. X and z, x here and z are lying on the same longitude, which is 105 degrees east. And that's why we would calculate the distance along that circle of longitude. Now, A and B are lying on the same latitude, and this latitude is what? Is 40 degrees north. So how do we calculate the distance along it? It's the same concept, because we are simply going to calculate the length of the arc, because it's along a circle of latitude, meaning that from A to B, it will be that part of the circumference of the circle. So, meaning it's an arc. A part of a circle is an arc. Okay, I have just tried to illustrate a diagram how to make this easier and how to understand this easier. So, the next diagram is showing a latitude 40 degrees north, and point A and B are lying on them. Okay, so let's look at this. So what I've drawn here is latitude 40 degrees north. So you can see the point A and B are still lying on the same latitude, which is 40 degrees north. We can all see that according to this diagram, A is lying on the longitude 15 degrees west. Same applies here. It's 15 degrees west. And when you look at the other one, it's lying on 30 degrees east. Even on this other diagram, it's still 30 degrees east, right there. Now, how do we get to know the length of the arc formed by the points AB? The same formula will apply. The only difference will be that in this case, the formula will no longer have the capital R. So meaning that it is still important for us to calculate the angular difference. The angular difference is that the arc formed by 2 points A and B has subtended on the center of the circle. Angle x degree is the angle that has been subtended at the center of this circle of latitude 40 degrees north by 2 points A and B. Therefore, the angular difference will come from longitudes. The angular difference will come from longitudes, meaning that to find the angular difference, we'll have to add the longitudes. Why am I adding? Because B is lying on 30 degrees east and A is lying on 15 degrees west. Two different opposite directions we add. Remember, west, east, we add is equal to we add. All right. So let's try and see how the formula will look like. So we know that for us to calculate that distance between the points A and B, which is forming an arc, we are going to say arc AB is equal to the angular difference subtended at the center of the circle by the arc over 360. That should be multiplied by 2, multiplied by the pi given, multiplied by the radius. Remember, the parallel latitudes or the circles formed by the parallel latitudes, the radius is found by r is equal to r cos x degrees. Okay? Don't forget this. We are no longer looking at greater circles. If the arc was on the latitude equator, we could have used a capital R here, meaning the radius of the earth should have been a capital R. But because we are dealing with the parallel latitudes, meaning that the radius is no longer standard, but it is reducing. Remember at the beginning of this topic I said, you can see that as circles are heading towards the circles formed by latitudes, as they are heading towards the North Pole and the South Pole, the circles tend to reduce in size. That indicates that the radius of those particular circles formed by the latitudes is also reducing. The radius will be reducing. Therefore, radius is going to be calculated by the formula, which is radius is equal to radius of the earth times cos x degrees, where x degrees here is representing the degree of the latitude. It is representing the degree of the latitude. So let's see, what does this now tell us? This tells us that if our formula is x degree over 360 degrees times 2 times the given pi times r, meaning that in this formula we always have to calculate for r for us to understand the radius of that particular circle. So this means radius is equivalent to what? R cos x degrees. So we are going to replace r here. We are going to replace r here with its equivalent. Its equivalence is r cos x degrees. So what we are going to do is the formula now will be x degrees over 360 degrees 2 multiplied by pi multiplied by r cos x degrees. Remember, do not confuse these two x's here. This x here is the angular difference or the angle subtended by the arc at the center of the circle. And the x degree here is the degree of the latitude. Let's look at how we can solve a certain problem. Let's say we were supposed to calculate the distance between A and B. A is lying on 15 degrees west, B is lying on 30 degrees east. Meaning, we are going to say 15 degrees plus 30 degrees. That is going to give us 45 degrees. So x is equal to 45 degrees. Remember, this x we found is the angular difference between point A and B. Okay? Now, let's go and start solving the distance. We are going to say arc AB is equal to x degree, okay, over 360 degrees times 2 times pi times r cos, let me just rewrite it somewhere here, is x degree over 360 degrees times 2 times pi times r cos x degrees. Now, what we have to do is replace x degrees is 45. Okay? This x degree here is 45. And this x here is, let's look at the latitude. Latitude 40 degrees right here. So this tells us that this one is 40 degrees, the degree of the latitude, and this one is 45, the angular difference. So let's do the replacement. Okay, let's take pi as 3.142 and radius in kilometers as 6,370 kilometers. Let's do that calculation. So we're going to say 45 degrees over 360 degrees times 2 times 3.142, okay, 3.2 times 3.142, okay, that's my point there, times, okay, radius 6,370, okay, times, I'll bring it down here, times cos, the latitude is 40 degrees. So let's punch this on a calculator. What is 45 times 2 times 3.142 times 6,370 times cos 40 degrees divided by 360 degrees? On my calculator, it's telling me that it is going to be 3,833.01 kilometers. This can be rounded off. This can be rounded off to the nearest 100, which is going to be, let me just write the rounded off one, which is going to be 3,800 kilometers. That's how we can calculate the distance between the 2 points along the circle of latitude. Let's try and see if we can apply the concepts from the past papers. Okay, this question is the same question I used in the previous video, but we only calculated 1, 2A. Those are the only questions we calculated. 2B we didn't calculate because we are not discussing on latitudes, we are discussing on longitudes. So now let's look at how we can solve this question. It's saying calculate the distance in nautical miles between Y and Z along the circle of latitudes. So Y is here and Z is there. They are lying on the same latitude, 30 degrees south. We have been told to calculate in nautical miles, meaning the radius is 3,437 nautical miles. Okay, let's get in the solution now. We are going to say our arc YZ is equal to x degree over 360 degrees 2 by r cos x degrees. So let's do the replacements. We are first of all supposed to understand the angle subtended by the arc on the center. So we will get that by looking at the longitudes where point Y and Z is lying on. So point Y is lying on 15 degrees west and Z is lying on 105 degrees east. Therefore, I would say 15 degrees plus 105 degrees. That will give us 120 degrees. So we found this angle here as 120. So we are going to replace that. We are going to say 120 over 360 is equal to, time is 2, time is the pi given as 3.142, time is 3,437. I'll bring it down here because of space. Time is cos the latitude where the 2 points are lying on is 30 degrees south. 30 degrees. So let's punch that we see on the calculator. 120 times 2 times 3.142 times 3,437 times cos 30 degrees is going to give us, times cos 30 degrees divided by 360. That is going to give us 6,234.84 nautical miles, which this can be rounded off to the nearest 100, meaning it will be 6,200 nautical miles. And that is how we can calculate the distance of point YZ along the circle of latitude. Now let's look at a next question. Our last example is asking us to find the distance between A, K, and L, because the first two questions there, we solved them in the previous video. So we are only looking at B. 2B, KL. The distance, find in kilometers, the distance KL. K is there, L is there. They are lying on the same latitude, and the latitude is 50 degrees north. This tells us that we need to find the angular difference. That can be found by calculating the difference between the longitudes where point K and L are lying on. So point K is lying on 30 degrees. Let's take note of that. 30 degrees plus, and point L is lying on 60 degrees. 60 degrees. So now we have to say 60 degrees plus 30 is going to give us 90 degrees. That is our angular difference. So then let's get into calculating the arc. So the formula obvious is the same. Arc KL is equal to x degrees over 360 degrees times 2 times pi times r cos x degrees, where again we are saying the x here is the angular difference and the x here is the degree of the latitude. So let's do the replacements. We are simply going to say, we are going to start with the x here, x degrees over 360, x, that is going to be 90 over 360 times 2 times 3.142 times, in nautical miles, I think, in kilometers, okay, sorry, in kilometers, which is 6,370. I'll bring it down here, times cos, the latitude is 50 degrees. So let's punch that on our calculator. What is 90 times 2 times 3.142 times 6,370 times cos 50 divided by 360 degrees? That is going to give us 6,432.55 kilometers, which can be rounded off to 6,400 kilometers. That is acceptable. That is also acceptable. And that is how we can basically or easily calculate the distance of 2 points along the circles of longitudes. Excuse me. Hopefully you've understood, but feel free to ask questions where you are not sure. Then try to go through some past papers, answer similar questions, and see how it goes. If you face any challenge with the questions that you'll be going through, just capture it and send it in the group, ask for help, and eventually we will get back to it. I'll get back to it as soon as possible. Thank you for watching, and have a blessed night.